Because cloud. So the presentation.
Already recording, right? Does it sound good?
If they can't hear you, just turn this on. I'm going to check and see. Как tu фамилию правильно произносить? Нет, ну чего, мне не привыкать. Я Садогурский, мне не привыкать. Моцевичус. 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 All right. So it's buttons probably. Ah, there we go.
Hello. All right. Guys, take a seat. There is tons of space here. Don't stand on the back. I'm loud, but Rimas is not, so you won't hear anything. And we're going to lock the door anyway, so standing by the door won't help. You won't be able to escape. So just come here and take a seat. Okay. Hello, everybody, and welcome to yet another JFrog Meetup. And today I am extremely excited because we have a wonderful speaker, a guest who is not a guest anymore. Right? So this is Rimas. I'll skip the last name. I tried and I failed, but
it's not that you have an easy last
I know, not it's just yeah. And you might know Rimas as one of the co-founders of Helm, the package manager of Kubernetes. And Rimas joined us here in JFrog to work on all kind of stuff. Obviously, Helm first, and he and the rest of the Helm team are working towards Helm 3. That will, you'll probably mention the timeline and the features and everything. I don't want to steal your thunder. Today Rimas is going to talk a little bit about how to work better with Helm 2 and what we are doing in JFrog, and he is doing as one of the contributors for Helm 3. One more thing I wanted to mention. Everybody loves to make money, and I give you an opportunity to make free money on behalf of your friends. We have a great referral program. If you go to join.jeffrog.com, you can sell your friends to us and get money out of it. Free money. Take a look there. And with that, this meetup is recorded and also streamed live. So you can go to our JFrog YouTube channel and see, obviously, see the video and share it with your friends. What else I didn't mention? I think that's all. So with that, Rimas. You will need your hands, right? So
yeah.
Demo and stuff.
So recording is fine.
Yeah.
You hear me fine? Because I don't want to forget.
No, you won't. That's cool. What we're working towards. Okay.
Cool.
Okay, we're good.
So you heard my name. I don't going to pronounce my surname. It's not for English people, not native Ukrainian colleague.
Okay, Rimas,
Yeah.
hold this, and I'm going to hook you up with like a mic for them.
Oh,
Okay?
cool. So I'm founder of Helm. I wrote a book about CoreOS. Have CK Kubernetes certificate and was early adopter of Docker in production early 2014. Was a good pain. So I wrote kind of a pass in bash to create containers on CoreOS because Kubernetes wasn't around at the time. It was a nice experience. So senior Frogger developer at JFrog. Oh, it's my Twitter account, please. So who is familiar with Kubernetes Helm? So, okay, so maybe 50-50, cool. Who is using Kubernetes production, pre-production, and Helm? Okay, listen guys, cool, awesome. So what is Kubernetes? I will do some short introduction to Kubernetes and Helm, so easy for newcomers. So it's a Greek word for helpman and a root of word of governor and cybernetic. It runs and manages containers, inspired by, informed by Google's experiences, internal systems, basically by Borg. Supports multiple cloud and bare metal environments. And of course, supports multiple container runtime engines. 100% open source, written in Go, like all those fancy, nice tools these days. Everything's written in Go. Manages applications, not machines. So we need something else to manage your machines, but Kubernetes does your application containers. So it's a 10,000 so somebody's not familiar. So we have API, CLI, UI, basically different clients talking to your Kubernetes masters, and afterwards containers get deployed via kubelets to different VMs or bare metal or on the cloud, basically cold nodes. So now I have Kubernetes. So now what? What I should do? So of course it should be easy too. Get up running with common workloads, define new workloads, collaborate on workload definitions, basically template files, specifying different parameters for application, how to run. As all you really care about is like talking to API and getting deployed your containers in a cluster. But it's not really like that. It's not so easy. Because when you take complicated application, it's not just one file you need to edit or deploy or update or make an upgrade. So this is why I came up with Kubernetes Packet Manager almost 3 years ago, basically. So why Helm? So why we invented Helm? So Helm is the best way to find, share, and use software built for Kubernetes. I think one of the best one right now. There are some different options, but community chosen this one because we have plenty of contributors contributing to Kubernetes Helm charts, Helm itself. So what is Helm? So Helm lets you and your team manage applications running on your Kubernetes. So basically, Helm charts let you define, install, and upgrade or even one most complicated application. So if you take a look to Istio chart, it's really complex, and so on, so on, so on. So having like Kubernetes templates, it's not so easy because you sometimes need to do minor change or some couple changes. You have to edit files, and that becomes more complicated in your, especially in your automation, like CI/CD pipelines. With Helm, we have, okay, so with charts, we describe even more complex apps. You can provide repeatable application installation and serve a single authority, basically, point of authority for a chart. And you can share your charts, host on public or private servers, and just easy to version. Even at JFrog, we have a Artifactory, which serves as private Helm repository. So easy updates. You just run Helm update. If your chart gets updated, some changes in the chart that will be rolled out, George. And only the things you change, which even a big chart, will be applied. Otherwise, you have to be careful when you're running your control command. And of course, bad things happen. So you have Helm rollback, because every release gets stored in Kubernetes by Tiller in config maps, or if you specify secrets as a Helm storage. And you can always roll back, look for history of your releases. So what is Helm? Oh yeah, so all that sounds true and sounds cool, very cool basically, but that brought, Helm v2 brought some security issues, and the community really not happy with why we had the Helm Summit back in last February, and there is already in works Helm v3 to solve loads of security issues. And since Helm v2, Helm got a server called the Tillerless server, which runs in your Kubernetes cluster, interacts with your Helm client, and interfaces with Kubernetes API, basically listening for incoming requests for Helm from a Helm client, combining a chart and configuration to build a release, and installing charts in Kubernetes, and then tracking the releases afterwards. So basically 2 parts. One, Tiller runs your Kubernetes cluster, Helm client sits outside your cluster, on your workstation, in your CI/CD pipelines. And of course, upgrading and installing charts by interacting with Kubernetes API. That sounds as an amazing setup. Of course it is, but it has some pain points. So currently it looks like this. So that's your Helm client, talks to Tiller, which sits in your Kubernetes cluster, and Tiller talks to API. It looks very simple, very nice, but it involves loads of security issues. So like in a nutshell, the client is responsible for managing charts and the server is responsible for managing releases. Which of course, that setup works very nice, very well, but some security issues, and the main one is that Tiller runs in your Kubernetes cluster with a full administrative right, basically like a root. Which is a risk is somebody gets unauthorized access to the cluster. So it's really bad. And imagine you want a multi-tenancy. So we have 10 different teams working. So you want to specify, allow them to work with one only namespace.
Keep going, keep going. Don't mind me.
Let's go down.
Keep going. Say something?
Hello? Hello?
No? Nothing? Nada?
Nothing? No.
Nada? Okay, what's going on?
Hello?
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 Hello? This will make noise. No?
Oh, yeah.
Oh, yeah.
Yes. Hello?
No?
Hello?
Again?
No. No.
Oh, come on. No, you keep going.
I will with two mics.
No, nothing? Nada?
Hello? No.
No.
Hello?
How about now?
Hello? No.
No. How about now?
No.
No.
What's working?
Yeah, what's working?
No. No, okay.
Okay, let's keep this mic.
Yeah.
I'll try to. When you do demos, I'll try to call.
I have another something to try. You keep going with the old one for now. And I'll try something else.
Oh.
Now this one doesn't work?
Oh, cool. So,
I'll keep trying.
So we'll back to multi-tenancy. So imagine running 10, 20 tillers in your cluster. Every tiller is separate namespace. And all tillers have a root access. Plus, vendors, TLS certificates, all that pain stuff you have to install. And the more tillers you run, of course, that starts consuming your resources. Because the more releases you do, the tiller uses more compute resources. Afterwards, right, to be secure, we have to use RBAC. So RBAC involves even more stuff to install and to set up. So we have to create a service account for tiller. So imagine creating 20 service accounts for 20 different tillers.
Question.
Yeah.
What's RBAC?
Role-based authentication. Yeah. So afterwards, creating a cluster role.
One more try. Okay, it makes noise. That's for sure. Speak.
Oh, yeah, cool. Awesome. Cool. So afterwards, you have to bind the collateral to a service account. And you have to deploy Tiller to, in this case, we deploy Tiller to system namespace. So let's do the real thing. So we created a service account for Tiller. Now we have to create a collateral binding. So give more authorization to Tiller, and now we have to install Tiller. We have in it specifying service account for Tiller. I have a alias for that, Caesar. So, okay, we've got a Tiller running. And imagine I have to run again, and then again. Plus, time comes, we get a new Helm version released. Okay, we have to upgrade all that stuff. So we have to kind of have a pipeline to upgrade your all tillers. Your TLS certificates get expired. Again, you have to deal with that stuff as well, again. And now we can install some chart, basically.
Launcher.
Okay. So we got our artifact to get installed. Cool. Sounds good. We see the Tiller running. Basically here. Awesome. That's Tiller sitting in our cluster, Helm talking outside of cluster using kubeconfig file. Now looking to best practices for securing Helm on Tiller from helm.sh. So you see so much things you have to take care of. So create a cluster to RBAC, cool. That's a pain. Especially your all apps have to support that. So you have to not only enable RBAC on your cluster, your all apps have to support RBAC as well, including Tiller. So configure each Tiller gRPC endpoint to use a separate TLS certificate. Release information should be set as Kubernetes secret. By default, Tiller stores in config maps. So install one Tiller per user, per team, or organization to entity the service account flag, roles, and role bindings. So use a like Tiller TLS verify option with the Tiller init and the TLS flag with over commands to enforce verification. So it just becomes a big mess. And if you have to maintain that afterwards, especially if you're not running, you want to have multi-tenancy. It becomes crazy, basically. So in a while, there are some workarounds, I see. So the most popular one is to pipe Helm template output to kube control, but basically avoiding to using Tiller. That's cool. That's easy. Let's do that. So, is there any who's not familiar with Helm template? What it does? Okay, so basically Helm template. Let's do this one command first. Show that. So basically, it reads a Helm chart and produces output with all values filled in. Basically, it's normal Kubernetes template file. So you pipe in that to kube control, create file. Cool, you get the thing deployed. Like in this case, okay, we have a certificate manager. Application, let's deploy it. All right, okay, I have to create a namespace, okay? Because when you specify a namespace to Helm, it will do for you. Now I have to do myself. Sorry, I use K instead of kube control, it's easier. Okay, now this command should work. Still something. Why is it? See, it should work, but now we have RBAC. I think it's already installed. Could be something happened in the middle. So see, it looks easy, but even if that works afterwards, what do you do? If you need to, you cannot use Tiller afterwards because you have to use those files separately, maintain them separately. You cannot use Helm upgrade or rollback, release history features anymore. There is no Helm afterwards. You just use a Helm chart output to a file. That's it, and you install it. I don't see that's a nice option. So like going back before even Helm was. Yeah, there is Chorus, Red Hat kind of ish operator which consumes Helm charts, makes operator, but still not Helm afterwards. There's a nice blog post how you use Helm with customize again. Making things around makes things worse. So, but it looks like the Helm v2 is not so difficult to use in a secure way. Basically, almost in the same way as planned for Helm v3. And even including your pipelines. So you can run Helm on your workstation or CD without installing any, like Tiller to your cluster. So you run this command, you export Tiller namespace, so you can specify the namespace you want. So, but if you don't specify that, it will go to the default kube system. You specify namespace, Tiller will store all releases in that namespace. Cool, that solves your one problem, multi-tenancy. Afterwards, you tell export Helm host, basically tell Helm where to look for Tiller, because you're running both on the same. So Helm knows to connect to localhost and port. And of course, Helm storage should be secret. It's not config mapped. Make it more secure. Okay, let's see that in action. So I have a same command. I create a namespace test basically to store my Tiller releases, basically after releases, and telling Helm host is localhost and Tiller to storage. Cool, Tiller is running. So we do Helm ls. Nothing there. So now we can install, let's install Envoy. Guys should be familiar with Envoy name these days. No? Istio? Yes. Big thing for Istio and Knative, whatever is around the mid. Awesome. Let's get installed. Check. Namespaces. Yeah, our previous install is running. Yeah, so getting installed. So cool. So that's easy, and basically afterwards it looks like this: Helm, Tiller, and Kubernetes cluster. So Helm talks directly to Tiller. Tiller takes over connecting to via kubeconfig to API server. So you have RBAC rules. You have anything specified for your user. Tiller will take will use that connection. Whatever you said, connection to your cluster, Tiller will use that. So we don't have to worry about anything securing your Tiller anymore. Because you run installation, whatever, or upgrade or check, you stop a Tiller, connection is gone. And it's not running into your cluster anymore. Yeah.
So what does Tiller do that Helm doesn't do by itself?
Can we leave questions afterwards? Because we have it. It'll be easier. So, Tillerless Helm security considerations. Basically, it really well aligns with Helm v3 security considerations. So, Helm now runs on the ID and permissions of Kubernetes user account or service account executing a command. So, as I mentioned before, RBAC now can be applied for each user. So, whatever we have, your kubeconfig file, Tiller will consume. Doesn't matter v2 or v3 users. And on the wire security is as secure as a cluster is configured to be. So we made your cluster secure, your connection secure. So Tiller reuses that. So you have TLS, it's easy to use. And the good plus, going this way, is basically switching from Helm Tillerless v2 to Helm v3 will be almost seamless. You swap a client and delete a plugin. And of course, we have to change a little commands if you're using plugin, but the whole pipeline stays the same. You don't have to reinvent anything. So auditability is now a feature of a cluster, as each shard is created by the user who runs a request. So whatever your RBAC rules apply, so we have a control for that. So Tillerless Helm has one con basically. So running multiple Tillers, like Helm instances, whatever, outside of cluster, different workstations, CI/CD pipelines. So only one drawback. If you do release for the same app, and that's basically impossible to get, but it's real line milliseconds, basically a release. So we could end up with the same release version. But you never do that because even you cannot do 2 releases to the same app basically in parallel because it won't work. So using serial release approach is the best using CI/CD systems. So to avoid release versions, this should just happen. Even if we're using Helm 3 or Helm 2, it will be the same. Of course, Helm 3 will be more clever. So we'll use completely different atomic commit approach. But still, best practices do release per app, not in parallel, but in serial way. So I wrote a blog post about Helm Tillerless. It's nice big, so it will be at the end of my talk, and slides will be shared. And with some small community input, we made it a very nice Helm plugin. So it's very easy to install the Helm plugin. Who's not familiar with Helm plugins? So basically, you expand a little bit. Helm plugin or group control plugins, basically, you use Helm plugin name and you can do things like, okay, let's install the Helm plugin. Okay, so it's such a cluster. That's such a cluster. Why do we look cluster? So I installed Helm plugin. Basically, just specify the GitHub repo, and it gets installed. Now, it has very simple commands, basically. So here, more documentation, that's easier to look. So Helm tiller start, what it does, it starts a tiller, as we saw here, basically. Opens to bash, and you can interact with the tiller. Sorry, with the Helm by tiller with your Kubernetes cluster. So let's do that. Plugin. It's clever enough as well. So it checks your Helm version, basic Helm client version, and downloads specific tiller version. One thing to mention, I'm using patch tiller version because the patch I did for only available in 2.10 tiller. So if you're not using Google Cloud or Amazon hosted ones, that's fine. You don't need a patch version of tiller. But otherwise, it doesn't know how to authenticate the Google Cloud or EKS, AKS. But that's all I think is ready to use. So basically, just install the Helm plugin, and it will fetch the right tiller. So Helm ls. Cool. So we see that, and we're running before. Oh, sorry. No. I left the tiller running. Let me kill that. Wrong cluster. Just okay, cool. So now I can use again different command, Helm install some chart. That's an interactive one. So it's easy to use for your workstation. You see extra output because that comes from a tiller itself. exists, okay. So we can use name to space frog. Cool. It's out, installs. Just do exit. And the stop. Tillerless stopped on my workstation. Now, to make, that's not really comfortable to do Helm start from Tillerless start. In your CI/CD pipelines, run something and do a stop. That's good for interactive, basically for developer doing something locally. But if you want to do in your CI/CD pipelines, there is command helm tiller run, which basically just we still have it. You're running from previous one. Yeah, cool. Cool. Very good. Okay, now we connect it to a new cluster. Basically, let's repeat your command. Tiller was running in background and was pointing to different cluster. Okay, let's copy the other cooker. Sorry. So can do again this one. Yeah, sorry. Hmm?
You need the second helm install.
No. Pardon?
It says helm to run helm install.
Okay. Usually demos always. Okay, 1 minute. Okay. Oh, okay, so I think going bash way usually it's easier. Cool, so we don't have anything, basically. Here. Yes, so easier. Left already. Okay. Yeah, but something, whatever, happened. Because it didn't switch properly between two clusters. But basically, you get an idea. Basically, you're running Helm run, and you specify a command, runs installation. If you have more things, like you can use bash, C, and afterwards you have multiple commands. Yeah, here's some. So, okay, so Helm v3. It's a big list. There is a URL afterwards. You can read about all this. So the main, just point a couple main ones. So Tillerless will be gone. So there will be only function combined in Helm, not like Helm and Tiller now. Charts will have new charts, v3 charts, and we'll use Lua language, and of course backward compatible with Helm v2 charts. So won't be a breaking change, changing from v2 to v3 Helm. Yes, and one interesting thing as well, there is a plan for Helm controller project. If you guys are familiar with controller, so we can do kind of a simple release, update, delete, Helm releases with CRDs. But that's, I did not touch it much. So I didn't see any work with that going through this. Basically now backporting, I think. The rest of the part. And of course, distributed index is coming. So that may when you land in the v2 Helm. So because right now the problem is with Helm repo, many PRs, too many PRs, they do not get merged on time. So you'll be able to use your Helm repo and add your public repo. And you will be in control of your Helm charts, releases, and all requests and everything. And of course, community can contribute to your Helm charts. That's for public one. But that could land in v2 as well. That's the main base touch, because if you want to read more, URLs here about Helm tree, Tillerless Helm plugin, and blog posts as well explaining. Okay, now we can take questions.
Is there a way to point
the microphone for the questions?
Yeah.
No, it's sorry, this is correct. Yeah. No, it's
okay.
It's only one.
Okay. So the question was like for Helm, we have Helm 2, and we have a lot of releases in Helm 2, which are managed by Tillerless cluster. With the plugin, can we point that plugin to point to the same config data and the release data that we already have, so that we can start managing?
Can you repeat the question for the streaming?
Yeah, I will rephrase it. So you can point, because by default, if you don't specify a namespace, you just keep system namespace by default. But you cannot point. You have to convert because plugin uses secrets. But if you're using secrets, you're fine. If you're not using secrets, you need to convert config maps. So, but I can show you a tool as well. Maybe I'll load it.
We just use the tool this week itself. We playing with one of the clusters and we just converted config maps to secrets.
We are already using.
Okay, we'll add the tool to slides afterwards.
Thank you.
So the tool basically converts your config maps to secrets, and you can specify you to transfer to different namespace. But if you're using secrets, you don't want to use the same namespace default one to the plugin, this will work. Because you don't have to specify it. Anything? Yeah.
Is there any APIs getting deprecated on Helm version and the timeline for version?
Alpha, public alpha, maybe end of the year. GA, summer, sooner. Depends. So it depends. If there are more contributors, maybe more companies contribute, it could be sooner. Depends. Because lots of jobs has been done. There's loads of duplication of the code in Tiller and Helm client as well, so that's getting cleaned up. So big refactor. But you going with Tilerless, it's easy for now, so you don't have to work. And it will be an easy transition. Usual demos, 50% they get work. I run that 10 times a day, I have no problem. No, but I didn't switch a clusters properly first. Yeah. That was my problem.
I looked at the demo twice today, but yeah.
The best advice of why we're going to switch cluster first cluster to use proper Tiller installation after Tillerless. Another cluster, I did forgot to switch cluster, and that was a problem. Yeah.
When you ran Tiller locally, you showed an export localhost :port. Are you listening only on localhost, or are you listening 0.0.0:port? So if I on my laptop, can I hit your Tiller, or are you limiting Tiller to only accept connections on localhost?
If you do like this, you're not limiting. But in a plugin, I'm limiting to only localhost. Because you have extra proportion. So in a plugin, I have running Tiller with basically, let me show. Scripts. Command so Tillerless. See, this limits you to listen. So I know when I walk around using in a cluster, you can use that, but this is the limits to only local host. So Tiller accepts only from local host. You cannot access from any. If you don't specify that, yeah, Tiller can accept from anywhere from network. This is basically by default.
And again, I guess the motivation is so that it uses the local kube config. Otherwise, it's probably not secure.
Yeah, these are local config. You apply your all rules, rules, whatever you have it. Basically, it will be reused. But Tiller, whatever, anything you are running, connect to API. That's a huge plus. Yeah.
With the Tiller on the server side, all the releases will be stored on the Kubernetes side, right?
Yeah, yeah. Tiller doesn't change. It doesn't.
Tillerless on the version 3, I assume that we are eliminating the Tiller that we are installing on the Netflix side. So where does the releases will be stored? Is it going to store locally?
No, releases all will be stored in a server on the API. How do we know about releases?
Yeah.
Oh, it will be still by API and CD.
Okay, so it directly uses the Kubernetes API to store.
Yeah, it's not changing anything because it doesn't matter where it runs. It depends how to connect to Kubernetes API, and it knows to store, I think, in Kubernetes etcd basically. So basically, you storing Tiller information, you can have our Tiller running, checking on different functions on CI/CD pipeline, even D3 or Tillerless D2, will work the same way. We'll see the same releases. So you asked a question about what is Tiller and Helm, right? Or you got already idea? So Tiller is a part of a basic server part which sits in a cluster or outside the cluster, and does accept the commands from Helm client, combines Helm chart always release to a release, installs, writes to etcd, basically talking to API, writes to Kubernetes API, via Kubernetes API to etcd, release version, I think some information about templates. And next time you do, it checks the release version, bumps the version again. If, again, it's a good question. One question before. So what happens if using Tillerless or V3, something happens in the middle of a release? Because what Helm does, it gets information first before deploying anything. It stores release in Kubernetes, basically, storage, and may put a status as progress. And only afterwards starts doing things. If something happens in the middle, it will be in progress, so you know the release wasn't finished. When the release is finished, the progress will be changed, it's finished. So that will be the same with V3, but I don't see a big problem with that. Because you can check afterwards in your CDs, pipeline basis, pipelines, status of your release, finished or not, success or not.
By saying that it's stored in the Kubernetes, you say that it's storage secret, or it's stored on the Kubernetes some?
No, Kubernetes secrets, config maps, whatever, every persistent data is stored in Kubernetes etcd. But yeah, it stores in a secret.
Okay,
information.
So actually etcd.
Yeah, when it's etcd, yes.
Okay.
So basically, that's a basic database for Kubernetes. But creates a secret, stores information in progress. If something happened, yeah, you'll see in progress, not finished, not success. If it's finished, success, done. So we can check out. Advisable to have a checkpoint afterwards. You have done the release. Of course, you can put the wait command. Sometimes good, sometimes not. So you have to find your ways.
So you mentioned some core having the Tillerless, right?
Yeah, so it's really, you can get that because basically if you do a release, so as I mentioned, when you push something via Helm to Tiller, it combines, writes the release information to secret, and if release was before it's on the release, so put some version number, like what release 1, so it will be release 2. If exactly at the same millisecond you run update for the same app only, for example, it doesn't matter, you can do many releases for different apps, that's fine, but by coincidence, that's basically millisecond or milli, whatever. You could overwrite your release, but that's rare. But you should be doing 2 releases to the same app in parallel. It's not the way you should be doing that. But that's a con. Geometry will have extra bits, fancy things too, just in case. That's the only con, but I'm not sure it's very easy to get that. But I just pointed out just in case to know. Any more questions? I think I'm clear. Cool. Thank you, guys. So that's recorded on YouTube, and we'll publish as well my slides. So we have all information.
Cool stuff. Thank you. Just do an end meeting from there. End meeting. And we're good. Awesome.